All right, everybody, welcome back to another fantastic episode of Bear's Guide to a 5. Now, before we get started, make sure if this is the first time you're watching the video that you're watching it on Edpuzzle, because it is a homework assignment. But if this is the second, third, fourth, 10th, 20th, 100th time you've watched it because you just love watching these videos, YouTube is the place to be. So, okay, we're talking about population pyramids today, and we have to be able to distinguish between population pyramids. But what the heck is a population pyramid? Because we've talked about population statistics, we've talked about the concentrations, we've talked about the demographic transition model. We know that populations change in a country over time based on economics, based on culture, based on medicine, based on education, right? But in each stage of the demographic transition model, in each year of a country's life, how can we look at the exact population breakdown in an effective way and be able to get ideas from that? And that's where population pyramids come into play. So what you're looking at is a very basic population pyramid. And what they represent is different levels of population growth at different stages of the demographic transition model, right? And based on what stage of the demographic transition model you're in or your country is in, the shape of your pyramid changes. So let's go through it. So population pyramids show population by percentage at each age level. The wider the part is, the more you have of that population percentage at that age level, right? On the left side going up and down, you have the 0, 10, 20, 30. So the bar graph is broken into groups of 5, 0 to 5, 6 to 10, 11 to 15. And then you just have percentages at the bottom going from 0 to 7. Now, males are always on the left, females are always on the right, and age goes from young to old on population pyramids. So what can these population pyramids tell us? Now, as I had already mentioned, we know all this other stuff about population and how populations change, but we want to get exactly at that second or in this specific time and place in history. What does the population look like? And what can these pyramids tell us? They can tell us what stage the country is in the demographic transition model. We can see the life expectancy for males versus females. We can see how many people are being born, and maybe we can explain major events like why is there a chunk missing of males ages, 60 to 70? Well, maybe there was a war and they all went off, or where there was a famine or a migration, a mass exodus of people. This is what population pyramids can. So on the topic of the demographic transition model and population pyramids, because they are the same. So if we go back, we remember that stage 2 of the demographic transition model is the population explosion. It's where you got a lot of births and the deaths suddenly drop. And we have this really high natural increase rate. We see the population ramp up, and that's what you're seeing here. We know that when they're in stage 2, they have that very wide base because they're having tons of people born. But remember, the population pyramid doesn't change shape because it's based on percentages, right? So until those births start to come down and people are living longer, this pyramid is always going to look this way. So stage 2 pyramids are always going to have that very wide base at the bottom and small at the top. But as we go through the demographic transition model, we know that in stage 3, those births start to drop and those deaths are still dropping. So now people are living even longer. Our populations are growing, and we're starting to see more people. Like I said, we're having people live longer, so they're taking up more percentages of the population. And now our population pyramid begins to change shape, right? Because we have lessened the births, so they don't take up as much population percentage. And older people, because they're now surviving longer, take up more of the percentage of the population. So we see it start to widen at the top. So you can probably predict what the next pyramid is going to look like if we move to stage 4. And we know in stage 4, we have 0 population growth. It's where the same amount of people leaving the game are the same people coming into the game, right? It's that 2.1 total fertility rate. And the population pyramid now begins to look like a rectangle. Well, as much as a rectangle as it can. As I mentioned, your births and deaths are equal, but you have that long life expectancy too. On this population pyramid, it shows people living all the way up until 85 years old. So that's a pretty long time, and we can tell this is a stage 4 country. So remember, As countries go through the demographic transition model, it changes shape. The shape of a population pyramid is dependent. The only thing that changes its shape is its natural increase rate, right? If you have a high natural increase rate, lots of births, it's going to have a wide bottom. If you have a lower natural increase rate, you're going to be closer to that rectangle. And this isn't something that happens over like a year or 2 years. This is something that happens over, decades of change in a country, because it takes time to change the culture, introduce opportunities for women, to drop birth rates, to provide contraceptives and better economic opportunities. And, all that stuff takes time. And if you don't introduce those things, we know that the natural increase rate will not change then. The total fertility rate will stay the same. So your pyramid changes or does not change shape. It doesn't matter if your population keeps growing. It can keep growing 1 million, 2 million, 3 million, 4 million. But if your percentages of the population are the same, your pyramid doesn't change shape. So these are the 3 population pyramids. We would ask what stage are they in? From left to right, left being stage 2, the middle being stage 3, and the right being stage 4. And with some regions in front of you. So now we look at another part of the population pyramid, the dependency ratio. So in countries, you have a group of the population that cannot work. They cannot contribute to the country, right? To the country's GDP, to the country's success, because they're old now, they're not working anymore, or they're too young to work. These are our non-workers. So dependency ratio, you can have an elderly dependency ratio or a higher young dependency ratio, but the fact is these people are dependent on the people working, right? Someone has to take care of these people because they still exist. And in our country, what we do is that the working people pay taxes to take care of the young people by sending them to school. They have stuff to do during the day. And we take care of the old people through services for them, Social Security, so on and so forth. So as I mentioned, in countries with a high dependency ratio, either youth or elderly, where you don't have enough workers, we have to figure out what to do. And this is the population problem we talk about, right? If you have too high of a birth rate and you have too high of a dependency ratio with the youth, well, what do you do with all these kids, right? And then on the flip side, if you have a ton of old people who are no longer working, well, you have to figure out how to use the budget you have in your country to take care of those old people, because you can't just forget about them. And these problems are then made even worse when we have baby booms or baby busts, which we will go into detail later. So what I want to show you here on the screen, what you're seeing is the population pyramid of Nigeria. And obviously it has a very wide base. So what you're looking at is an imbalanced youth dependency ratio. You have a lot of people who are dependent on the workers who cannot work. Now, in these countries, these kids probably do work, or they work on a farm or something like that. But at the end of the day, we have a large amount of kids for whatever reason that may be. But in the developed world, and say like Japan, you have a imbalanced elderly dependency ratio problem. So dependency ratio problems exist, but you have to be specific if it's youth or elderly. Now, the problems that come with imbalanced dependency ratios, we will explore in future lessons, but it's important to start to understand that. So what I want you to think about is predict what regions of the world that will suffer from a high youth dependency ratio or a high elderly dependency ratio. Basically, you're thinking of the regions of the world, you're connecting how you know if regions are developed, high developing, or developing, and you're going to try to attach dependency ratio to them based on what I've told you. All right, so I wanted to show you the population pyramid of Italy and how we could use that to kind of look at events. So in this, we see at 1, we have a decline in the birth rate because this is a developed nation. And as countries develop, we know that birth rates drop because people don't need kids, don't want kids, kids are expensive. But at 2, we saw a baby boom. So that means after some type of event, you had one large baby boom, which could be really scary because by the time they get really old, you're going to have an elderly dependency ratio problem. 3 indicates there are fewer men in Italy who are older because of World War I and World War II, that men just died because they went and served. If you look at 4, it shows that women live longer. They have a higher life expectancy because there's more women at that age. It could be a mix of also the results of the world wars. And then finally, if you look at 5 verse 1, that dependency ratio problem. When you have too many old people and not enough young people, you have a worker shortage. If you have a worker shortage, that means they can't pay taxes. If they can't pay enough taxes, then the government can't take care of the old people, right? And that could be really dangerous for a country. Yes, Italy is known for its aging population, which also, to bring in COVID-19, is the reason why Italy had such a huge reaction to the pandemic, is because their country is so full of older people. And now, if they follow this trend, we can see what it looks like on a population pyramid. Then in 2025, we have this. And then we have a very imbalanced elderly dependency ratio if their declining birth rates continue, which they normally do in developed nations. All right, so not only can we use population pyramids to analyze countries and look at what countries have gone through, we can use it at different scales. And we know that if we change the scale of our analysis, if we zoom in on a small map and increase the scale, or we zoom out and make a big map with a small scale, obviously the data will be different. And what we've been looking at this entire time is small scale analysis. We've been looking at a country as a whole. So what changes as we zoom in, as we increase that scale? So the United States has a pretty straightforward population pyramid, kind of stage 4-ish, kind of stage 3-ish, because we are so large. So what happens when we zoom in and increase that? Well, we look at Alaska and we think, wow, I can't even tell what stage this is, and why are there so many people ages 30 to 50 years old? Why are all these dudes in Alaska? Well, that's what we use. And we see and we think, okay, well, what's in Alaska bringing all these men there? And we go, oh, economic opportunity, right? So this is just how we can use these population pyramids to think about country development, scale analysis, and the future of countries. So what do you need to know today? Well, you got to know what population pyramids are, right? You got to know how to use population pyramids and how they correlate to the demographic transition model. Like, what will my population pyramids look like in each stage, and what does that tell us? And then finally, be able to connect all population statistics back to population pyramids. I'm talking your CBR, your CDR, your TFR, your IMR. Like, how do all those change the shape of population pyramids, especially when we're talking about NIR? And one thing I want to add on to, or two things I want to add on to what you need to know today. One, how do you pull apart population pyramids to maybe think about events that have happened in a country's history? And two, how does scale affect population pyramid size? So as always, this was Bear's Guide to a 5. Make sure you smash that like button and you hit the subscribe and the little bell icon so you know when new videos are released, so you can stay up to date on what's happening.